Hello, Math 2. This video is part 2 of 4 on factoring, where we're going to factor polynomials, and specifically we're going to factor quadratics. And when we look at a quadratic, we know it's ax squared plus bx plus c, but this first lesson is going to be when the value of a is equal to 1. So every quadratic you factor will look like x squared plus bx plus c. So first we're going to talk about what are the prime factors of 10. When we look at the prime factors of 10, right, we are going to say the prime factors of 10 are 2 and 5. That's because these numbers, right, are the prime factors and they multiply to 10. So when we look at polynomials, how can we factor these polynomials? Okay, so in this case, if we look at this being the quadratic trinomial, okay, and we want to go from this to a product of two binomials. So we want to make it look like x plus c times x plus d, where c and d are numbers. How could we go from x squared plus 7x plus 12 to a product of two binomials? Well, let's look here. If I gave you these two binomials and I asked you to multiply them out, right? X times x is x squared. X times 4 is plus 4x. 3 times x is plus 3x. 3 times 4 would give you 12. And if I simplify inside, that would give me x squared plus 7x plus 12. So how could we go from this all the way back to here? Right? That's what we're looking to do when we factor. So the conclusion here is the binomials x plus 3 and x plus 4 are the prime factors of x squared plus 7x plus 12. This means when you multiply them, you get x squared plus 7x plus 12. So let's take a look here. If I had these two binomials and I were multiplying them together, if I created this box with squares, I know I can take the x minus 3, put it up top. The x plus 5 here. Now, just as we would go ahead and distribute, okay, we're going to show that inside the box here. X times x is x squared. Negative 3 times x is negative 3x. X times 5 is 5x. Negative 3 times 5 is negative 15. So when I multiply this out, I get x squared. Now, negative 3x plus 5x is going to give you plus 2x minus 15. So when we multiply this out, whether we FOIL it, multiply them, or use the box, we get x squared plus 2x minus 15. So when I look at the next one, right, x times x will give me x squared. X times 2 would give me 2x. 6 times x would give me 6x. 6 times 2 would give me 12. Right? So this would give me x squared. 6x plus 2x is going to give me positive 8x, so I add it. And then 12 is positive, so I'm going to add 12. So let's change it up a little bit. It says here, find the missing value if the product of two binomials results in x squared plus 12x plus 35. So right away we know this x times x will give us x squared. We know x times 7 will give us 7x. But you have to understand, we need 12x and we need 35. Well, if I look up here, so when I look, this x times 2 gave us 2x. This 6 times x gave us 6x, right? And eventually, this 6 times 2 gave me 12. So here, when I look at it, 7 times what would give me 35? That would be positive 5. And then is 5 times x going to give me 5x? Yes. If I add these together, 5x and 7x, does that add up to 12x? Yes. So if I look at it, if I took x plus 5 and multiplied it by x plus 7, I would get the polynomial I started with. So this is what we're talking about when we're coming up with factoring. So again here, if I had to rewrite this in factored form, what times what would give me x squared plus 13x plus 30? Well, I know over here I have to have x and x to give me x squared. But now, think about this. How do I get 30 here? There's many different ways to get 30. I can go 10 times 3. I can go 15 times 2. I can go 6 times 5. I have many different options here. But the thing is, I need whatever multiplies to 30 to give me 13x. So, hypothetically, say we put plus 6 plus 5 here. Oh, 6 times 5 would give me 30. However, 6 times x would give me 6x. 5 times x would give me 5x. That would only add up to 11x. But if I take and write it as, if I use 10 and 3, plus 10 plus 3, now that gives me 10x. Now that gives me 3x. So 10 and 3 multiplies to give me 30 and adds up to that middle term. So this would factor out to be x plus 10 times x plus 3. So to factor this quadratic, we basically find the numbers that multiply to 30, add to 13. In this case, we said it's 10 times 3, because 10 plus 3 gives us 13. So now, x plus 10 times x plus 3 is what we get. So that's the key here is, if I have to factor x squared plus bx plus c, I need to find what multiplies to give me c and adds to give me b. Once I find those, say I said that was r times s, I know r plus s has to add up to b, so we would factor it x plus r times x plus s. So let's take a look at a couple of examples here. Okay, we want to factor this. What multiplies to give me 8 and adds to give me 6? Well, I know I have 8 times 1, I have 4 times 2, but 8 plus 1 gives me 9. That can't work. 4 plus 2 gives me 6. There we go. So basically, we're going to factor this as x plus 4 times x plus, not 6, sorry, x plus 2. Now we have factored that quadratic. Next one, we have to find the numbers that multiply to give me negative 16, add to give me negative 6. Now in this case, I have to look. This has to be negative 16, so I know one sign has to be positive, the other one has to be a negative. Okay, so if I did say negative 8 times 2, negative 2 times 8, negative 4 times 4, right? I can use any of these combinations. Which ones add up to negative 6? Negative 8 plus 2 gives me negative 6. So these are the factors I'm going to use. So now remember, if the number is positive, we add it. If it's negative, we subtract it. So x minus 8 times x plus 2. And that's how we factor that one. Next one, we have to multiply to get 21 and add up to negative 10. Well, what numbers multiply to give us positive 21? Add up to that. If this number is positive and this is negative, One thing you have to note is both numbers will have to be negative. So in this case, if I did negative 21 times negative 1, negative 21 plus negative 1, that would be negative 22. That doesn't work. But negative 7 times negative 3, negative 7 plus negative 3, that gives me negative 10. So the numbers that multiply to give us 21 adds up to negative 10 are negative 7 and 3. So we use x minus 7 times x minus 3. Next one. What numbers multiply to give me 27 and add up to 12? In this case, 27 and 1 adds up to 28. That doesn't work. 3 times 9 is 12, right? Or sorry, 27. Excuse me. And they add up to 12. So I know those are the factors I'm going to use. X plus 3 times x plus 9. Now, just to let you know, anytime you're factoring, you can switch the order of the binomials. So another answer here could be x plus 2 times x plus 4. That would be acceptable. Here, x plus 2 times x minus 8. That would be good. In this case, x plus 9 times x plus 3 could also be an answer. All right, any of those could be an answer. So as we move down, real quick here, what I want to think about, what multiplies to give me negative 24 and adds up to 2. In this case, that's going to be, so this is negative, so I know I have to have one positive and one negative. In this case, I know they're going to basically subtract, so I'm going to look at it as 6 and negative 4. So this would factor out to be x plus 6 times x minus 4. Number 12, what numbers multiply to give you negative 12, add up to negative 1? Well, in this case, if I did 6 and negative 2, right, those would add up to 4. That doesn't work. If I say 4 and negative 3, those add up to 1, but I need negative 1. So I'm going to flip the signs. Negative 4 times 3. Negative 4 plus 3 is negative 1. There we go. So this would factor out to be x minus 4 times x plus 3. The next one, what multiplies to give you 100 and adds to 20? In this case, 10 times 10, because 10 plus 10 is 20. So x plus 10 times x plus 10. The last one, what multiplies to give me 12 and adds to negative 7? Well, I know this is positive, so both have to be, that's positive, that's negative, so they're both going to be negative. So negative 4 times negative 3, that gives you 12. Negative 4 plus negative 3, that's negative 7. So these factors work. So x minus 4 times x minus 3. Now the last example here is, what happens if we have a greatest common factor? You always have to factor out the GCF first. So in this first example, they found that the GCF was 2. They pulled it out, divided everything by 2 to get this remaining polynomial. Now when I look at x squared minus 10x plus 21, what multiplies to give me 21 adds to negative 10. Well, negative 7 times negative 3. So we would completely factor this by our GCF times our binomial times our binomial. So in this example, I look GCF, all of them can be divided by 2. Now, can I factor the remaining polynomial? What multiplies to give me negative 30 and adds to give me -1. Well, in this case, it'd be negative